This is RD Sharma Solution Class 12, Chapter 17. We are taking the VSAQ, very small answer question of increasing and decreasing functions. Write the set of values of k for which this fx is equal to kx minus sin x is increasing on R. So increasing means what? It should be greater than 0. What should be greater than 0? The differentiation should be greater than 0. F dash x should be greater than 0. So what we are going to find, first of all, the differentiation here. Kx differentiation is k. Sin x differentiation is cos x. So k minus cos x, this is what we got. And increasing means this content or this term or this expression should be greater than 0. What does it mean? K is greater than cos x. So you can also say other way around, cos x should be greater than k should be greater than cos x, or cos x should be less than k. What is the value of cos? It can attain -1 to 1. So k is greater than the cos x. That means the highest value of cos x, which is 1. And till what point we can go? 1 till infinity. This k should belong to 1 till infinity. Now this is the solution, and it's very straightforward and easy question if you have followed the previous questions which we have discussed. If gx is a decreasing function on R and fx equals to tan inverse gx, state whether fx is increasing or decreasing or not. Okay, gx is a decreasing. What does it mean? We know the definition of decreasing function. If x1 and x2, they belongs to a real number can be any number you know. And the x1 and x2 is such that x1 is less than x2. So when we have x1 less than x2, the gx1 should be greater than gx2. That is the definition of decreasing function, right? So now what we'll do is we will take tan inverse on both the sides. Tan inverse gx1 greater than tan inverse gx2. So the inside content, don't worry, just worry about tan inverse. See, tan inverse will be greater than only, because tan inverse 0 is what? 0. Tan inverse pi by 2 is what? It's infinite. So when it increases, that is from 0 to pi by 2, if things increases, then the value also of tan inverse thing increases from 0 to infinite. So it's a kind of increasing function. So tan inverse gx should be greater than tan inverse gx2, and as I said, the sign is not changing, because as we put tan inverse, if x1 is less than x2, tan inverse x1 will be less than tan inverse x2. Or you can say if x1 is greater than x2, tan inverse x2 will be greater than tan inverse x2. So we have x1 and x2. This, as I said, we always take it. And fx1 we got the greater than fx2. So if x1 is less than x2 and fx1 is greater than fx2, okay? If x1 is less than x2 and fx1 is greater than fx2, that means this is actually a decreasing function. It is not following the trend of x1, x2. It is against the trend. This is again a straightforward question. If you know the property of tan inverse, I don't think there will be any trouble of you knowing how to solve this question. This is how you're going to write it, because writing is very important. The question can be tan inverse, cos inverse, sin inverse. Write the values of a set of values of a for which the function fx is equal to ax plus b is decreasing for all x belongs to R. Now, there can be any easier question than this until now. The differentiation of dash x is only a. If you differentiate it, you'll get a. Decreasing for all x belongs to R means f dash x should be less than 0. That is, a should be less than 0. If you take the number line, what are the numbers below than 0 until you can go to negative infinity? So a should belong to negative infinity to 0. This is the set of values of way which a can take for decreasing function of this one, and this is the solution which you have. Write the interval in which sin x plus cos x, where we have x belongs to 0 pi by 2, is increasing. Again, that means 0 to pi by 2, it might be increasing somewhere, it might be decreasing somewhere. That is, it is asking in which point, which interval this function is actually increasing. We have fx, so I'm taking the differentiation of dash x. Sin x will be cos x will be minus sin x. So f dash x should be greater than 0. Cos x minus sin x should be greater than 0. That is, cos x should be greater than sin x. Now you can take both sides, divide by cos x. So cos by cos x, here sin by cos x, you get tan x. 1 is greater than tan x. Or you can say that tan x is lower than 1, less than 1. Now you come here, tan x is less than 1. You know the value of tan 0 is 0, tan in pi by 2 is pi by infinite. You cannot define it. Okay, so there has to be something in between. So when you get tan x equals to 1, it is at pi by 4. Tan x is pi by 4. Now this 1, so anything which is less than 1, then this is from this to this, 0 to 1. This is the only range, or you can say the shaded area where tan x will be less than 1. And what is this? This is in between 0 and pi by 2. Pi by 4, which is actually between 0 and pi by 2. So we will talk about 0 to pi by 4 because tan x is less than 1, and we know that tan x equals to 1 only at pi by 4. Okay, center we are talking about. From here to here it is increasing for sure. Again, this is the solution which you can refer while writing somewhere or in your examination. And this question is very easy if you have understood the previous chapter exercises. State whether tan x minus x is increasing or decreasing its domain. Now let us see. When you don't know anything, just differentiate. F dash x is tan x is sec square x and minus 1. Now you tell me, what is sec square minus 1? Because there is a relationship between sec and tan, sine and cos, cosec and cot. So whenever sec square come, you see the tan x, you will use the tan square x, tan square theta is equal to sec square theta minus 1, or sec square minus tan square is equal to 1. So in place of sec square x minus 1, we can always write it as tan square x. Now this tan square x, anything with a square makes it positive, greater than 0. That means tan square x is greater than 0. And when we say it is greater than 0, we are talking about the domain in between 0 to 2 pi. See, if you start with 0, the domain will come where? You go all around the circle, all quadrants. So from 0, all these through, you reach to 0.2 pi. So it will always be positive. This function will always be increasing. Now, diagram is very important. If you can draw the diagram and explain it, it will be very beneficial for you. I can tell you that. Write the set of values of a for which fx equals to cos x plus a square x plus b is strictly increasing on R. We have the value of a strictly means f dash x should be greater than 0. It should not be equal to 0. Greater and equal means it is increasing. Greater the only greater means it is strictly increasing. We have the differentiation tool. We will differentiate it. Cos x is minus sin x. You have this as plus a square. B will be 0. You got a square minus sin x. A square minus sin x. This f dash x, if it is increasing or strictly increasing, it has to be greater than 0. That is, a square minus sin x should be greater than 0. A square should be greater than sin x. Now, again we came to the same point. Sin x is between negative 1 and 1. This is negative 1. This is 1. Sin x between these two. Sin x, if a square is greater than sin x, what is the highest value of sin x? The highest value of sin x is plus 1. Alright. So actually a square greater than sin x is only indicating that a square has to be greater than 1. Bring 1 here, you will get a square minus 1. And a square minus 1 square, you know that a square minus b square is a minus b into a plus b, right? So a square minus 1 square is a minus 1, a plus 1. Now when we have this as a minus 1 and a plus 1, these are two different factors, and when this factor multiplied, it is greater than 0. The first point which when I started this chapter, we told how you are going to get it. What will be the solution? That solution we are going to apply here, because a minus 1 is 0 when a is 1. A plus 1 is equal to 0 when a equal to minus 1. So we have 1 and minus 1. These 1 and minus 1 means what? It is the critical point. This is the critical point, negative 1 and 1. So it will go up 1 or go below a negative 1. So 1 to infinite, this one the first thing, and less than negative 1, which is negative 1 to infinity. And the final solution will be the union of this. So x should belong to this whole interval in order for this function to be strictly increasing on R. This is how we are going to do it. This is how we are going to write it. Please note it so that we may end this exercise. Thank you so much. Take care of yourself.